From the first homework where I gave you a list of the different types of numbers, you should recall that a rational number is anything that can be written as a fraction. So when we're dealing with fractions, we're dealing with rational numbers, or if we've got algebra in there, then rational functions. So everything we've been looking at so far has been a rational function. What we're going to look at today is proper rational functions. Now, we're dealing with fractions. Proper fractions, hopefully you'll remember from primary school, are ones where the numerator is less than the denominator. When we're dealing with a proper rational function, then the highest power in the numerator should be lower than the highest power in the denominator. But it's not always that way in what we're given in the question. So we're going to take this as two parts. The first part, I'm going to show you how to turn an improper rational function into the whole number bit and a proper rational function. And then I'll show you a second example where we do that and then we go on to do the partial fractions with what we have. So the example we're going to use is x cubed plus 4x squared take away x plus 2 all over x squared plus x. Now if we look at the numerator and we look at the denominator, the highest power in the numerator is x cubed, the highest power in the denominator is x squared. We need the highest power to be lower in the numerator than they are in the denominator, and they're quite obviously not, they're greater. So what we're going to do is we're going to do algebraic long division. Now back in the olden days, this is how you did numerical division. Sadly times have changed, so this is probably the first time you're ever going to see a division written out like this. So what I'm dividing is the x cubed plus 4x squared take away x plus 2, so that goes inside my division. And what I'm dividing by is x squared plus x. I'm going to write it out slightly differently. I want to write it in descending powers of x. Well, they are descending powers of x. I've got x to the power of 2, x to the power of 1, but I'm missing a term with x to the power of 0, i.e. a number term. So what I can do is I can just put plus 0 on the end, because obviously adding on 0 doesn't change the value of the function, but what it does is it gives me terms that I can compare. Now, when we're doing any division, what we essentially do is we look at the number we're dividing by and say, what do I need to multiply that by to give me the first term in what I'm dividing? So I'm looking to say, what do I need to multiply this by to give me x cubed? Well, to turn x squared into x cubed, I need to multiply by x. So that's what goes on the top of my fraction. Writing it out slightly differently to how we normally would. I'm going to be writing x onto the top of my division. These are essentially columns with the different powers of x. My x column is here, so I'll write the x on the top. Now what I'm going to do is I'm going to times everything here by x and then take it away to see what I've got left. So x times x squared is x cubed, x times x is x squared, x times 0 is 0x. This is essentially what you do when you're doing a number division anyway. We've done our multiplication, we've said how many times does this thing go into this. Now we're looking for the remainder. The remainder is what you get when you take away your two answers. So I'm going to do a takeaway. X cubed take away x cubed is 0. 4x squared take away x squared is 3x squared. Negative x take away 0x is still just the negative x. Now, I only had 3 terms here, so I've only got 3 terms here. But there is this plus 2 still there as well. I've just not done anything with it. So we've done the first part of our division. We've got our remainder. essentially. This is what you'd sort of slide into the division into your next column when you're doing a normal division calculation. Now we do our comparisons again. Again, we're saying, what do I have to times this leading value by to turn it into this leading value? Well, to turn x squared into x cubed, I'll multiply by 3. So I'll multiply everything by 3. 3x squared plus 3x plus 0. Then again, take it away to find out what the remainder is. So I've got 3x squared, take away 3x squared is 0. Negative x, take away another 3x is negative 4x. And 2 take away 0 is 2. I'm sorry, the cat's trying to get in the video. This is my remainder. So this bit will stay in the fraction. The bit on the top is essentially our whole number part. So rewriting this fraction, x cubed plus 4x squared, take away x plus 2 over x squared plus x is this x plus 3. That's our whole number part. This bit is our remainder. It stays in the fraction. So it stays in the fraction with the same denominator as before. I'm going to swap the terms over because we don't want to start with a negative in our numerator. This was an improper rational function. We've got the whole number part, and now the fraction is proper because the highest power in the numerator is lower than the highest power in the denominator.